We know your plans. We shall not let you destroy our world. Who is your creator?
Oh, you question me? Me? The Rhombus? Oh, how dare you question me? I'm way too high class for you.
I'm really trying to get me to spill your answer. I ain't spilling nothing, bro. Just because I'm a rectangle doesn't mean I'm weak.
Maybe they're related to the parallelogram.
To recap on our findings of the parallelogram, let's look through its properties. Both pairs of the opposite sides are congruent. Both pairs of opposite sides are parallel. Both pairs of opposite angles are congruent. Both pairs of consecutive angles are supplementary, which means they add up to 180. Diagonals bisect each other. There's a picture of a parallelogram!
Okay, so we have a parallelogram in this first warm-up. That's like review. So if you already did the work, you should have set them equal to each other. Once again, is because diagonals and parallelograms are bisected by each other. And then we simplify this, and you get 10x equals 8x plus 14. And then you simplify that by subtracting 8x from 10x, and get 2x equals 14. Divide by 2, and you get x equals 7. And for the next problem, you simplify, and you get 2y equals y plus 13. And then you subtract the y, and you get...
So, here we are going to find the angle measures of the parallelogram shown. We know that A and C are congruent, and B and D are congruent. So we set up the equations to equal each other. And we know this because both opposite angles in a parallelogram are congruent. So solving the equation, we subtract 2x from both sides, and then we subtract 4 from both sides, so that 8 equals x, and then we plug 8 back into the equation to get 28. So angle A and angle C are both 28 degrees, and then going on to the next equation, you solve for y, and then plug y back into the equation to get 152. So both angle B and angle D equal 152. Quadrilateral duck is a parallelogram. Find the lengths of the sides. So here you get DU set equal to KC and DK set equal to UC, because both pairs of opposite sides of parallelograms are congruent. And from there we start to simplify by subtracting 271 from both sides, and then 8x from both sides, so you get 82 equals x. And then you subtract y from both sides, and 7, and you add 7 to both sides to get y equals 28. And then from there you plug all of the values back into the equation, so you get du equals 1009, kc also equals 1009, uc equals 49, and dk equals 49.
We should check their memory cards.
Okay, so we found out the memory card information of rhombus. Okay, so first thing we found is a quadrilateral is a rhombus if and only if all the sides are congruent. Interesting. A parallelogram is a rhombus if and only if its diagonals are perpendicular. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. This is so useful in solving the crime.
Now we're checking the rectangle's memory card. According to this, a quadrilateral is a rectangle if and only if it has 4 right angles. A parallelogram is a rectangle if and only if its diagonals are congruent.
Okay, parallelogram, did you make these evil shapes?
We know you're involved. They have your properties.
Okay, so now we have squares memory card. Let's check this out. Let's see. So we have rhombuses data and rectangles data. If we put them together, we get square. So that way, a quadrilateral is a square if and only if it's a rhombus and a rectangle. It all makes sense now. And there's this big old family tree of evil parallelograms and rhombi and squares and rectangles all created by parallelogram.
Mother.
God.
So we know that ABCD and EFGH are similar rectangles. So we can say that segment AB is proportional to EF and AD is proportional to EH. So we set up a proportion. So we have 10 over 5 equals x over 7. And then you cross multiply, so 5x equals 10 times 7. Simplifying that, you get 5x equals 70. Then you divide 5 from both sides, so x is 14. So EF equals 14 inches. And because opposite sides are congruent in a rectangle, EF equals HG, so this makes HG 14 inches.
Example problem 2. Specify if the parallelograms are a square, rectangle, or rhombus. So right here is our first shape. And we know that these two opposite sides are congruent, but it's kind of given since it's a parallelogram, but what else? And then we have two right angles, but let's say, because it looks like a square, so we want 4 right angles, but we don't have any. But then there's a 45 degrees and a 45 degrees, and since you know a triangle has 180 degrees, you can say that this would also be 45, because 45, 45, and 90 is 180. And then it's also parallelogram, so that would also over here would also be 45. So then by that, you can say that this side right here is equal to this side right here, and it's also equal to this side right here, and equal to this side right here because of isosceles triangles of doom. So it's a square. And right here, it looks like a rectangle, so let's see if it can be a rectangle. You have one tick mark here, another tick mark here, and here, and here. And it's like, okay, so the diagonals are bisected, but they're all equal. So that means that the diagonals are congruent. So therefore, since it's a theorem of a square or rectangle, it's a rectangle! My bad. And this one, it just pretty much looks like a parallelogram, but what if it's a rhombus? Well, you know, this is a parallelogram. Since this is 60 degrees here, this alternate interior angle also makes this over here 60 degrees. So since this is 60 degrees and this is 30, it's a 60 degrees, and since this is a triangle, it has to add up to 180, so this angle right here would be 90. Therefore, making the diagonals perpendicular to each other, since that is a theorem of a rhombus, it is a rhombus of doom. Thus, show that parallelogram ABCD is a rhombus. Well, we have these given measurements, that DB is 8. And since we know the parallelogram is bisected, so this is 4, and this is also 4. And AD is 5. And AX equals 3. The parallelogram is 3. Well, if you look at this, you can say that, well, this is also 5 since it's a parallelogram. Congruent opposite sides. Woo! Okay, anyways. Well, this is triangle right here has side lengths of 4, 3, and 5, which is a Pythagorean triple or triplet. So this should be a right angle because it's a magical right triangle. And therefore, it is a rhombus because the diagonals are perpendicular. A, B, C, D is a square. Find the measures of A, E, and B, D. Okay, so since it's a square, we know that the diagonals are perpendicular, so you can say that's the right angle, and all of these other beautiful angles are right angles. Anyways, moving on. Okay, so since we have 14, well, first off, actually since it's a square, you know that these are bisected, so this is 45 degrees. Go to the center, and it's an isosceles right triangle, so, and this is the longer side, so that means 14 equals x. We're out of
you divide by radical 2. But sadly, since radicals are horrible, horrible little creatures of doom, I'm not even joking, you can't have one on the bottom, so you multiply by that. 14 radical 2 over 2, which simplifies to 7 radical 2. Therefore, this is 7 radical 2, and this is also 7 radical 2, since it's isosceles. So those are implicits, you know, theorem or something of a square of doom. So, but that's not our exact answer. So find the measures of AE, which we found out. So AE equals 7 radical 2. We also want BD. And since it's a square, that means the diagonals are bisected. So that means this is also 7 radical 2. So that means this is 14 radical 2, since you times 7 radical 2 by 2 and 14 radical 2.
Okay, so here's our challenge problem, and you might want to pause the video now to read what this actually says, because I'm not going to read through it just to save time, and I already went ahead and labeled the picture here. But anyways, it says that there's 10 feet here, and there's 2 feet wide, so I labeled that. And what we want to find is the area of this triangle right here is our first step. But first we need to find the lengths. Well, since this whole figure right here is a square, since it was kind of hinted in here, and also the diagonals are perpendicular, this would be a 45, 45, 90 right triangle. So therefore, we want to find this length first, since we can easily do that. So if we have 10, subtract 2, and subtract 2, we get 6 feet. And since it's a 45, 45, 90, 6 feet right here is equal to x radical 2, which if you divide both parts by radical 2, you get 6 radical 2 equals x. But you want to multiply by this, because you can't have radical on the bottom, so you get 6 radical 2 over 2, which simplifies to, oh my god, sorry there. But anyways, this simplifies to 3 radical 2. So both of these sides are 3 radical 2. Okay, so we have our side lengths. The next step we want to do is find the area. Well, the area for a triangle is 1/2 base, which is 3 radical 2, times the height, which is also 3 radical 2, since you want to make sure that the base and the height are the ones that are perpendicular to each other. So this simplifies to 1/2, 9 times 2, which is 1/2 of 18, which is 9 feet squared. So this whole area is 9 feet squared. Okay, so now that we have the area, the next part of the problem is we want to figure out how many flowers fit in this area right here. Well, if we can see that 100 flowers fit in a 36 square feet. Well, 9 square feet is what we have here, and thankfully 9 goes into the 36. So if we have 36 divided by 9, we get 4. So if we take the 100 flowers that are in the 36 square feet and divide that by 4, we can get how many flowers fit into here, which is 25 flowers. So now that we figured out how many flowers fit in here, we want to figure out how much these flowers cost. So if each flower costs 25 cents, we simply take 25 times 0.25. And since I don't know that off the top of my head, I'm going to pull out my calculator and simply plug in 25 times 0.25. And you find that your answer is $6.25. So this would be your final answer.